Good day, grade 11s, and welcome to today's lesson. What we're going to do today is trigonometry and with general solutions combined with specific solutions. So we're going to work with general solution in a specific interval and especially without using a calculator. That will be very interesting. Now the example that we're going to work with is this one, sine 2x minus 5 equals to cos x minus 35, and x must exist in the interval minus 180 to 360. Very interesting enough, you will see we don't have specific values over here that we can equal either side to. And you will see the tool that we're going to use is co-ratios, where sine 90 minus theta is equal to cos theta. So just stay put. I'm going to my desk and we're going to do the example from there. Right? See you just now. Good. Yes, let's continue from here now and see what we need to do. Right. Solve for x, where sine 2x minus 5 equal to cos x minus 35, where x exists in the interval minus 180 to 360 degrees. Right, so let's see. We don't have definite actual values that we can equal either the left-hand side or the right-hand side to. But we have a sine and a cos. And those two angles differs from each other. So what we can do actually is to work with co-ratios. Co-ratios. We can say that the sine of 90 minus theta is equal to the cos of theta. Let's work with that and see if that can bring us some light to this problem over here. So let's write the sine of 2x minus 5 is equal to, let's write the cos in terms of sine, making use of my co-ratios like this one over here. So we can write the cos of that angle as 90 minus theta, but not theta. Just have a look over here. This whole angle I will treat as theta then. So the 90 minus theta will then be this whole angle. But let's put it in brackets. Either we can make a sign mistake. So this x minus 35 is actually now my theta if I'm working with my co-ratios then. Okay. Good. Let's simplify this a bit and see how this looks. So we have the sine of 90 minus 35 gives us 125 minus x. So what we have here now is the following. We have a sine over there and we have a sine over there. So that means that this angle, this bracket, is equal to this bracket over here. That is the one thing that we need to see. The other thing is, in front of this sign, there's an invisible plus sign over there. So we need to determine in which quadrants we're going to work with. So sine is positive. Where's sine positive? Sine is positive in my first and in my second quadrant. Working in my second quadrant is 180 minus. So let's rewrite my solution now for both these quadrants. Let's start with quadrant number 1. 2x minus 5, this one over there, is equal to 125 minus x, and remember the general solution. Remember the general solution. Let's simplify this. The minus x goes to that side, becomes a 3x. The minus 5 goes over there, becomes plus. So we have a plus 130 plus my general solution. Good. Now I need to go and divide by 3 so that I can isolate the x. So I divide by 3. So I have x equals to, now if I divide 130 by 3, we get 43,33. 43,33 plus, now remember, we need to divide this 360 also by 3, and that is 120. Remember, and n is element of my integers. Right, so this is my first general solution for my first quadrant. Let's jump over to the second quadrant. Here we say that 2x minus 5 is equal to, and remember in my second quadrant we're working with 180 minus. 180 minus what? Minus this angle over here. This one is 125 minus x. 125 minus x. And again, you see, I'm using brackets to make sure I don't make a sign mistake at all. Let's simplify this a bit. So 180 minus 125 gives us 55. Minus x gives us plus x. Simplify the equation. The x goes to the left hand side, becomes negative, so I end up with x over there. Minus 5 comes over here, becomes 60. But we just need to add our general solution. We nearly forgot. Okay, plus n dot 360 degrees. Okay, so these are my two equations that I'm going to work with. N is element of my integers. So I'm going to work now with that equation and this one over here to get my specifics for a solution between minus 180 and 360. And we can only solve it by inspection, actually. What do I mean? So we need to substitute n equals to 0 to get to an answer, and n equals to 1, minus 1, 2, minus 2, and so forth. So let's start with n equals to 0. If I substitute 0 in there, then that becomes 0, so I'm only left with 43,33 degrees. Jump to this one over here. N is 0, this whole term becomes 0, so I only have a 60 degrees over there. Okay, let's inspect n equals to 1. 43,33 plus 120. Plus 120, that gives us 163,33. Right. Let's use this one over here. If that is a 1, we have a 360 plus a 60, jumps over 360. I'm not even going to calculate that at all. So it's beyond the interval over there. Let's inspect n equals to minus 1 then. We have 43.33 minus 120, and that gives us a 76,67 minus 76,67 degrees. Okay, let's go to this one over here. What are we going to get? We're going to get a 60 minus a 360. It will be minus 300, and minus 300 will be to the left of 180. Not going to use that one. I suspect we need to go a bit further and inspect n equals to 2 as well, because we have only a 120 there. It's not a 360 or 180. So let's just check what's going to happen. So we have the 43.33 plus 2 times 120. And that gives us, a 283. And yes, a 283,33. And that exists in the interval between minus 180 and 360. Right, I think we can stop there because if I substitute 2 in there, it's not going to work. If I go for 3, it's not going to work there. So actually these are the only solutions for x between minus 180 and 360. So these are my solutions. I'm not going to rewrite that, don't have time for that in the exam as well. I'm just going to state x is element of these numbers over there. Good. So just to recap, just remember, always calculate your general solution in this scenario. Working with cos or sine, remember your co-ratios. Once you've got your general solution, then with inspection, you need to calculate what is the value for x when n is equals to 0, get an answer. For n, get an answer. For n equals to -1, get an answer. And just test your answers over here. Just test it to see if it exists in the interval that's been asked. Right, thank you very much. Thank you, grade 11s, for watching this video, and have a great day. Thank you.